In this video, the master instructors from Best Incorporated will demonstrate the procedure for mounting a wire to a bifurcated type terminal. The sample used in this video is not mounted to an electronic assembly, so the procedure will involve the use of a terminal holding device. Select the appropriate gauge wire for the terminal. In this case, the wire is a 22 gauge wire. Strip and clean the wire to a length sufficient to wrap around the terminal plus a little extra. The extra length of the wire can be trimmed to the final length after the wire is wrapped to the terminal. Wires that are wrapped to terminals should be tinned prior to forming the wire to the terminal. Apply flux to the area of the wire to be tinned. Using a large thermal mass tip and solder wire, create a heat bridge between the soldering iron tip and the surface of the wire. Keeping the iron tip in contact with the wire, apply solder from the opposite side of the wire down toward the end of the wire. Some solder may wick under the insulation. This is acceptable as long as the wicked section of the wire is not required to remain flexible. Clean the wire with a stiff bristled brush and a cleaning solvent to wipe away any debris, residues, or surface oxides. Place the wire in contact with the terminal, leaving approximately 1 wire diameter from the insulation cut end to the point where the soldered connection will begin. A wire diameter is defined as the diameter of the wire conductor and the outer diameter of the insulation. Wrap the tinned wire directly to the terminal. Use a wooden stick or other tool that will not damage the wire, terminal, or the assembly. Trim the edge of the wire approximately even with the edge of the terminal post. Once again, use a large thermal mass soldering iron tip. The tip selection should be able to quickly heat the wire and the terminal. Create a heat bridge between the iron tip, the wire, and the terminal. Apply solder to the opposite side of the termination so the solder can flow around the wire and terminal toward the soldering iron. Be sure to leave enough time for the connection to cool completely before movement of the assembly. After the assembly has cooled, clean the connection using a stiff bristled brush and lint-free wipe. Be sure to scrub the assembly well to remove any remaining unactivated flux, flux residue, or other contaminants. Wipe the assembly dry with a clean wipe. Inspect the assembly according to the IPCA 610 document. The IPCA 610 groups electronic assemblies into 3 classes. These classes are based on the intended end-use environment for the assembly. Class 1, general electronic products, are those where the major requirement is that the assembly is functional. Class 2, dedicated service products, are assemblies where continued performance and extended life are desired, but not critical. Typically, the end-use environment would not cause failures. Class 3, high performance or harsh environment products, are assemblies in which high performance and performance on demand are critical. Downtime cannot be tolerated, or the extreme environment may be uncommonly harsh. According to the IPCA 610, on a Class 3 assembly, the insulation can extend to and even touch the soldered connection, as long as it does not interfere with the required soldered connection. As a maximum, the insulation can't be more than 2 wire diameters from the connection, and the exposed wire cannot cause a potential short between other objects on the assembly. The wire must be wrapped a minimum of 90 degrees around the terminal with a preferred wrap of 180 degrees. If the wire is wrapped more than 90 degrees but less than 180 degrees around the terminal post, 100% of the wire to terminal contact area must be soldered. If the wire is wrapped 180 degrees or more, as little as 75% of the required wrap can be soldered to the terminal. Solder should rise between the wire and terminal and along the terminal base so that any depression between the surfaces is not more than 25% the radius of the wire. The end of the wire cannot extend beyond the terminal base far enough to cause a potential short to other parts of the assembly. Visit and follow us on our YouTube channel, Soldering Geek, for more videos. For training classes, supplies, and more, visit our website, www.solder.net.